The next example doesn't look exactly the same as the typical linear first-order linear differential equation. We used to see y prime plus something comes with a y and then another terms on the other side. But this time we have cos x in front of the equation. Let me rearrange the equation and make it look similar to what we used to see. Let me divide the entire equation by cos x, which means I will now end up with 2y tangent x, and on the other side, divided by cos x, we end up with secant x. So now, I have one equation with this y at the back. Let me consider this as one piece. And we will use this to find the integrating factor. But don't forget to include the negative in front of it, because a linear differential equation usually start with a plus. If this middle term comes with a minus in front of it, your integrating factor will now involve negative 2 tangent x. We can integrate this into e to the 2 ln cos x. This is to start with a u substitution. Let u be cos x, and as you differentiate this, the cos x will turn into negative sin x dx, and as you integrate 1 over cos x, 1 over u, you end up getting your ln, and that turns into cos square x. E and ln, they offset each other, and the 2 in front of it can now bring it back to the exponent using the law of logarithm. So if this is the new term we will multiply to everywhere, we are now dealing with cos square of x dy dx minus, as I multiply this by cos square, one of the cos x will be cancelled with the cosine in the denominator of your tangent. So that turns into 2 sin x cos x times y equals, on the other side, multiply secant x by cos square. That can be simplified to 3 times cos x. So the left hand side came from the product rule involving these two terms, cos square x. There's definitely that one part will come from here, and then the second part would then be the y. And now we are ready to integrate both sides of the equation. Integrate this with respect to the x, integrate it with respect to x, so that the left hand side will turn into cos square x times y. And on the right hand side, integrating this shouldn't be that difficult. Sin x. Now don't forget to have your plus c after you integrate it, because this is an initial value problem. We will now solve for the constant using x equals 0 and y equals 1. When x equals 0, this part will turn into 0. When x equals 0, that part turns into a 1. And here, when y equals 1, 1 times 1 equals 1 on the left hand side. So that will give us c equals 1. And that means if I'm to find the equation, an explicit equation for y, I will have y equals 3 sin x plus 1. Once again, the constant term equals 1, and divided by cos square of x.